We have completed one problem in the previous video. So in this previous video I told you that S is equal to 36 and S is equal to 54, both satisfy the limitation. So from that, which one I have to select? But in the previous problem I completed using this, but why I am selecting this value though these two values are satisfying the condition? Okay, so just I explain. ZS is equal to total number of conductors per slot is equal to 1452 divided by 36 40, and 54 divided by 54 is equal to 27. Okay, so in this one, the third point, if you are seeing that previous videos, selection of stator slots, there are 4 conditions. That fourth condition is it should not exceed this slot loading. The values should not exceed the slot loading, correct? Now I want to find out the slot loading. Slot loading nothing but ZSS multiplied by IZ, current flowing through the conductor multiplied by number of conductors in a slot. Okay, so 40, for example, we are selecting the first case 1, that is S is equal to 36, and S is equal to 36, ZS is equal to 40. I have calculated here. Okay, at that time the slot loading is equal to 487.32. Clear? So I want to find out the slot loading for this case. So slot loading is equal to ZSS multiplied by EZ. So ZSS here 27 multiplied by phase current 12.183. At the time still the value is minimum. So 328.941. Okay, so there are two values. From this we want to select any one particular value. Normally the slot loading should not exceed 750 ampere per conductor. Not per conductor, ampere conductors, like MMF. Slot loading should not exceed the limit 750 ampere conductors. So both the values, here it is 487.32, here it is 328.941. Both the values are very less, but it can go up to 750. So the nearer value is 487.32. This is still very less, but here this is towards 750 ampere conductor, so I can select this value. So this value is related to 40 is related to 36. That's why in the previous problem I have selected this 36. Hope you would have understood this. Now I am going to start this next topic in this chapter. Dear students, in this video I am going to continue with the next topic, design of wound rotor, that is slip ring rotor. This covers the lecture number 46 to 49. Okay, so you know about slip ring induction motor, just you are adding external resistance, correct? So by varying the external resistance you can able to improve the torque developed by the motor. So this rotor is made up of laminated core and semi-enclosed slots, and also it consists of 3-phase winding. In your squirrel cage induction motor it consists of bars, but for your slip ring induction motor it consists of 3-phase winding. This diagram represents your slip ring induction motor. The slip ring induction motor rotor consists of 3 windings R, Y, B. So it may be connected in star, otherwise delta. Here star connection. See here, the center part is connected together, and this orange color represents the shaft of the motor. Orange color represents shaft, and the next end of the winding is connected with slip ring. So these are all, this violet color represents your slip ring. This violet color represents slip ring. Okay, so with this slip ring the windings are connected with the slip ring. The slip rings are connected with your external resistance. Slip rings are connected with external resistance. So while you are varying this resistance, automatically here you are changing this RYB resistor, so automatically it will affect the torque of the motor. Correct? This is actually your diagram here. Now we want to find out some design values for your rotor. So first one, you want to find out number of rotor turns. Similar to your stator turns TS, here you are going to find out TR. So rotor is like a secondary of transformer. I told you that the induction motor is called as rotating transformer. It consists of primary winding in the stator, secondary winding in the rotor. Also, you want to consider voltage between slip rings. So between the slip rings, what is the voltage you have to consider? It should not exceed the limit. It should not, because you are connecting the resistor, automatically it will the voltage between the two slip rings